Uh, Welcome, students, to another lesson. Since we have promised on providing a lesson on tree diagrams, so now we'll be focusing on the tree diagrams, right? Now we'll be focusing on what you say. Okay, now we'll be focusing on the tree diagrams. Remember from the previous lessons I've mentioned that especially at grade 12 level or at grade 12 level or grade 11 at grade 12 level or grade 11 level you're gonna have three things, right? Only one of the two will be there in your exam or a test, right? It's either they're going to give you a tree body, not a tree. Okay, okay, a tree diagram or or either a tree diagram or or a Venn diagram or a what? It's a tree diagram, a Venn diagram, or a contingency table, right? But now on this lesson we'll be looking at the tree diagrams. I'll be teaching you on how to draw the tree diagrams and being able to interpret the statements, right? And application to those tree diagrams. You see. So now here we see a question, right? And then I want you to know that if you notice, especially when we're dealing with these aspects of graphical presentation, the theory behind this is not that much and it's not really important, right? But what is the important is the application, you see, and the techniques that you really need for you to be able to answer the questions, right? Now we look at question 8, right? So I'm going to teach you on how to draw these three diagrams looking at question 8, right? So we have question 8. We have question question 8. And some of you may be wondering, why am I starting with a question? Right? Now you will see whenever you get the gist of it. Alright, because this is it's a common question, or we say it's a standardized question or an example in relation to the topic. So what happens? We're saying, okay, we have question 8. So question 8 reads as follows: a bag contains 6 red balls, 8 green balls, and unknown number of yellow balls. The probability of randomly choosing a green ball from the bag is 25%. You see? So now let's check. Okay, we've been given, okay, now we know that, okay, here we have a bag, right? In this case, and then they're saying a bag contains 6 what? It contains 6 red balls, right? 8 green balls, and unknown number of yellow balls. The moment you see an unknown number, the moment you see an unknown number of yellow balls, just simply let the unknown be x. So how many balls do we have? How many yellow balls do we have? Now in this case we have x yellow, we have x yellow balls. Do you understand? We have x yellow balls in this case. Now we have question. Let's look at question. Okay, we have x yellow balls. All right. So we were told that, okay, the probability of randomly choosing a green ball from the bag is 25%, meaning the green balls constitute 25% of the balls in the bag. You see? So meaning our 25% is equivalent to what? The 25% of the balls in the bag will be equivalent to the number of green balls. So how many we have? 8 what? We have 8 green. Right. So now we have the first question. Let's look at question 8.1. So question 8.1, they say, okay, show that there are 32 balls in the bag. We need to show that there are 32 balls in the bag. Now I want you to note, right, that in this case we just simply have to write whatever it's given and then you substitute, right? How do you substitute that? Now here's the question. Okay, now listen. So the first thing that we're going to do in this case, okay, the first thing that we're going to do, okay, we'll say, okay, here we have a tree, here we have a tree diagram, right? So let me do this first. Um, okay, okay, okay. Let's do this. So we are asked, okay, here's 8.1. So in this case, we are asked to show that we have to show that there are 32 bars in the bag. You see, so they never asked anything about the yellow box, the yellow box, but they asked about the total number of the bars. Now in this case, we have to show that there are 32 bars in the bag. You see, so we were told, okay, okay, let me do this. We were told that the probability of choosing a green ball is 25%. Now, this is something that we have to use, right? We were told that the probability of choosing a green ball is 25 what? 25%, right? Meaning 25% of the balls is what? Meaning that 25% of the balls, listen carefully, 25% of the balls are the green balls, and we know the number of green balls, right? Since we know the percentages that the numbers hold in the bag, so we can be able to find the total numbers. So how? Okay, we know the first thing, we know that 25% is the probability of choosing a green ball, which means that, okay, 25% of the balls that are there in the bag are green balls, and we were given the number of green balls. So what do we do? Okay, you will say, okay, I have 25%, and then first, before we can conclude, let me just simply say this. We were not given the number of yellow balls, right? What did I do? I said, okay, let the unknown, which is let the unknown number of yellow balls be x, right? And then now I still have another unknown, which is the total number of the balls. Now I'll let the total number of the balls be equivalent to y. In this case, these are variable. You can use any variable. You can use any alphabet you want to use, right? And then I would say, okay, on 8.1, I'll let okay I'll let the total number of balls in the bag. Okay, so I'll do what? I'll let the total number of balls in the bag be equivalent to what? Be equivalent to y. Now x is the number of yellow balls, is the unknown number of yellow balls, right? So what do we know? We know that 25% of y, of how many balls? 25% of the balls in the bag are green balls, right? So we will try to find, we are going to find the 25% of y. So we need 25% of y. We know that 25% of, the moment I say of in maths, we'll do what? We'll multiply 25% of y. I will multiply 25% by y. We know it's equivalent to the number of green balls. How many green balls do we have? The number of green balls in this case is it's 8, and 25% is the same as 0.25 y, which is equivalent to 8. Now in this case, I'm looking for y. What's my y? We said y is the total number of balls in the bag. So I'll divide both sides by what? I'll divide both sides by 0.25. We divide both sides by 0.25. Okay, let's calculate it. Okay, we have 8 divided by 0.25. Okay, let's do this. Yeah, that's 32. That's 32 what? 32 balls. Meaning we have 32 balls in the bag as what as required. You see, so now looking at this question, it's just a one mark question. Now listen, the first thing that you do, you label what's given. We know that we were given 6 red balls, 8 green balls, and we were not given the number of yellow balls. What did I do? I said, okay, the unknown number of yellow balls is equivalent to x, which is any variable, right? And the other thing, we were told that the probability of choosing a green ball in this case is 25%, which is the same as 25 over 100, right? So what do? I know that 25% of the balls constitutes the number of green balls, right? So yeah, it's a one mark question. Let's just simply leave it, right? So now we know that the total number of balls is 32. Now we can be able to find the number of yellow balls, even though we were not asked. Right. Now we can find what? Now we can find the number of yellow balls. Now, what is the number of yellow balls in this case? The number of yellow balls in this case. Now we know that all of the balls, we know that red balls plus green balls plus yellow balls, all of them are equivalent to 32. In this case, my y represent the yellow balls in this case. It does not the same y, right? So how many balls do I have, right? Which is my R. Okay, how many red balls do I have? I have six red balls. And then how many green balls do I have? I have 8 green balls. And how many yellow balls we were not given? Or I can just substitute x, since I said let x be. Since let me just simply substitute x in this case. Since I said let x be the number of yellow balls. All of them is okay. All of them the sum of these numbers is equivalent to 32. What do? I'll be left with, I isolate my x, and then what is 32 minus 8 minus 6, which is 18. Now I know that I have 18 yellow balls. Even though we were not asked, but we are going to need these whenever we are going to draw our tree diagram. So what happens? I say, okay, we have 8.2. 8.2, they're saying a ball is drawn from the bag. So it simply means that a ball is taken out of a ball is taken out of the bag. So they're saying a ball is drawn from the bag, and the color is recorded, and it is not returned. It is not returned to the bag. I want you to know that whenever they draw the ball from the bag and they do not return it, it simply means that they take it without replacement. You see, so whenever they take it without replacement, the number of balls reduces because of they do not return the ball, they do not replace the ball, so they take it without replacing the ball. You see, so as time goes by, whenever we still withdraw those balls, we still draw. Whenever we still draw those balls, what happens is that we are saying the sample size to what it decreases. In this case, the sample size to what decreases. So okay, let me just simply try to open a new page, or okay, let's just simply read it the question, right? Maybe I can use this space, but if you are going to draw a tree diagram, it won't be sufficient. So what happens now? They say, okay, a ball is drawn from the bag and the color is recorded. Okay, it is not returned to the bag. So the moment we do not return, we explain that we take without replacement, and the sample size decreases because we do not replace the ball. Thereafter, another ball is withdrawn from the bag. So we withdraw. It's not withdrawn. It's drawn. Sorry, it's not withdrawn. It's drawn. So what happens is that we draw the first ball from the bag. We take the first ball, and then we take the second ball without retaining both balls. Without retaining both balls, right? So, and it is also not returned to the bag, right? So what? Okay, 8.2 says draw a tree diagram to represent all possible ways in which the two balls could have drawn from the bag, and show probabilities associated with branch, okay, which each branch as well as the outcomes. Okay, now let's analyze this a bit. Now the first thing that I know is that I have to draw a tree diagram in this case. I have to draw what? A tree diagram. Now, how do we draw that tree diagram? Because this is what you've been aiming for. So now listen. In this case, we were given how many balls? We know that we have 3 colors of balls. Now, in this case, 3 colors of these balls is the same as having three events, right? And then 3 events in this case will be will be will be uh will be will be represented by what? Okay, it will be, let's do this. Let me try to do this. Okay, now we have 3 events, right? So when we were doing Venn diagrams, I explained that the moment you have the number of events in the Venn diagrams, right? Because it represents the what? It represents the number of circles. The moment you have 3 events, you have three circles. The same thing applies with the tree diagram. The moment you have three events, it simply means that you will have 3 branches. How many branches will you have? You have 3 branches, right? And then we are withdrawing how many balls? We are withdrawing 2 balls, not at once, but one after the other. You see? So now, how are we going to draw this tree-body diagram? So we know that we have how many? We know that we have 3 events, which is in this case R will represent my red balls, G will represent my green balls, and then Y will represent my yellow balls, right? So now what do we do now? I'm gonna have, okay, let me try to clean up this space. You see, I'm gonna try and clean up this space because I'm gonna need it. Okay, we were able to find the number of yellow balls we know is 18. Let me I want to try and erase this so that we can have enough space. You see, yeah, let's do it. Let's erase. Okay, so what happens is that now we have to draw a tree diagram, right? And then it's a tree diagram because of, not because of, but in this case we are taking without replacement. And when we take the balls without replacement, what happens to our n? It decreases, right? And what do? We take one after the other. So now I'm going to have my choices, right? So at first we will draw the first ball. So this will represent the probabilities of the first ball. So how do we draw the tree diagram, right? Because of you have 3 events, you will have three branches, right? So this is my first, okay, this is my first branch, right? I'm gonna have the second branch here, and I'm gonna have the third branch here, right? And then you have to name each branch, right? And then to make things simpler, just simply the sequence of the startup sequence of the events, right? Doesn't we don't really care whether you start with red or green or red, but just simply make sure that you maintain consistency throughout the tree diagram so that you do not confuse yourself, to make things simpler for you, right? So now the first branch I will choose to name it R, right, which represent my red balls, right? And then the second one will be G, and then I'll have Y. So this is the branch of my first ball. Now this is the branch representing the first ball that I'm taking out of the bag. You see? So now we know the total number of balls. Now the total number of balls in this case is 32, right? And I told you that whenever you determine the probabilities, what happens? We said whenever you determine the probabilities on in the numerator, you will have the total number of favorable outcomes, F, favorable outcomes and possible outcome. We know that possible outcome in this case will be our sample space or sample size. Now, what is the total number of what is the probability of choosing a red ball in this case? We have our first choice. So we start with the sample size. How many balls do we have? We have 32, right? So how many red balls do we have? We have 6 red balls. Now that is the probability of choosing the first red ball, of choosing the red ball, right? So of choosing the first ball, which is red in color. Now we have the green. We head to the green. So what happens here is that the same thing applies, right? So mind if you check I'm writing my probabilities on top of the branches, right? And then after I do what, I name those branches. You see? So the probabilities of choosing a green ball, how many green balls do I have? You check. You have 8 green balls. Over how many balls? Over 32 balls, right? And then what happens with my Y? I have 32 balls, and then what happens with my yellow balls? I have 18. I have 18. So that I have 18 yellow balls, and the total number of balls we know is 32. Now this is my tree diagram for my first choice, right? That's for my first choice. That's the choices that I would have if I were to choose a ball from the pack. You see, that's the first thing. Because now in this case, they said, okay, this person chose to withdraw how many balls? Two, one after the other. So this one represents the choices of the first ball. Now we need the second ball. What do? We extend the branches. Now in this case, each event will have how many branches? Will have 3 branches in this case. Let's say each event will have 3 branches in this case. Okay, I'm just triangle. Yeah, right. And then the sequencing, we maintain consistency because of I have already started with the red ball. Even in this branch, I'm gonna start with the red ball, right? The same thing. We have G for the green ball, and we have yellow, and then I will still have R, G, yellow, R, G, Y, right? So now what happens now? The second branching, if you look at this branching, this one represents the second, this one represents the second bar, right? Now this branching represents the second bar. Now listen to me. We've already took from the first, if you look at the first branching, we're saying we have already took what? We have already took the first ball. Now we are looking at the second ball. If we have already took the first ball out of the bag without retaining it, it simply means that the sample space decreases. Now the total number of balls in this case is no longer 32, but it is 31. So I know that in this case my sample space will be 31 in this case. Why? Because of I have already, okay, I'll try to write green here, right? That will be my green, and then I'll have my yellow in this case. Okay, now I know it's 31. It's 31. Please bear with me. I'll try to, okay, to make sure that you acknowledge them, right? So now I know that because of I've already taken a single ball. Now because of you are looking at the choices of choosing the second ball, I haven't yet chose the second ball. These are the chances of me choosing the second ball. I've already chosen the first ball, right? So now if looking at this branch on red, if you check red in this case, this thing shows that okay, this branch represents the following, that you've already chose a single ball, right? And that ball, because of here the branch is rooted from a red ball, it simply tells you that you have taken the red ball. So you have taken a red ball. So for the fact that I had 6 balls, so what happens when I take one ball? I had 6 red balls, and then I took one red ball. How many balls will I will I be left with? I'll be left with 5 red balls. Now my probabilities changes. I will have 5 over 31. 5 represented that I've taken a red ball. Why? Because of this branch, the second branch, it's rooted from, it's rooted or it's created from this R, which tells me that I've already taken a red ball, right? Now, did we take a green ball? No, no, no. So we still have the same number of the green balls. We still have we still have the same number of green balls. In this case, because of I haven't yet choose a green ball. How many green balls are there in the ball? In the bag, I have 8. I have 8 green balls, so I'll have 8 over 31. And then for white, the same thing. I didn't choose any yellow red ball, any yellow ball. So what did I choose? The only thing that I choose was a red ball, meaning the number of yellow balls remains the same. Now here I'll have 18 over 31. And I repeat, this 31 is the sample space since we have taken what? A single ball from the bag. You see? So now what happens on the second branch? Now we look on this branch. Now we look at this branch. So what happens at this branch is that we have 31. You see? So we know the reason why we have 31. Now this branch is rooted from what? It's rooted from G. Since it's rooted from G, it tells you that no, we have taken a ball from G. We have taken a green ball. That's why now we have 31, right? Meaning we haven't touched the red balls and we haven't touched the yellow balls. We only took one green ball. So now what is the probability in this case of choosing a red ball? Now I know that since I took a green ball, now my sample space will be 31. How many red balls do I have? I still have 6 red balls because in this case I haven't chosen any red balls. And then for G, which is okay, we know which is sample space is 31 because of we chose this G. So how many? So from 8 green balls I chose 1, so which means I will have 7 over 31, right? And then now what happens here on, okay, on yellow, I haven't yet chose a yellow ball. Now I'll still remain to have 18 18 18 yellow balls. Now the probability will be 18 over the sample space. Now we head to the last branch, right? We head to the last branch, okay, to the last branch, right? So what happens on the last branch? Let me try this probabilities daily for you to be able to see, right? Because some of you really complained. I'll just simply try to write them down clearly. Say okay. I'll just try to jot them down clearly. Okay. Let me just copy these now. Let me just enlarge it so that you can be able to see, because I see it that you won't be able to see. Okay. So now, okay. So how many? Okay, let me make it big. Okay. Now you can see. Now you can see, right? Now you have R, you have green, you have J, and then now you. Okay, this one. Let me. Okay. Okay. Yes, you see. Yeah. Yeah, I've tried. Yeah, I've tried my best. You can see that I tried my best. Now you can be able to see. Okay. Yes. Yeah. So here we know that the sample space was all over 32, right? 32. And here we had 6, here we had 8, here we had 18. And then what happens? Here we had 5 over 31. Here we have 8 over 31. We still have R, G, Y, R, G, Y, R, G, Y. Okay, this G. Right. So what happens here? We had 18 over 31. Here we had 6 over 31. Here we had Okay, he had 7 over 31, and then here we had what? Here we had 18 over 31. Now what happens on the same day on the last branch? Now here we are on the last branch. On the last branch we are saying the last branch is rooted from y, it's rooted from the yellow balls. So it simply tells you that we have chosen a yellow ball. Now we haven't yet touched the red balls. So what is the probability of obtaining a red ball in this case? I will have, how many red balls do I have? I have 6 over, I've taken a single ball which is a yellow ball. From 32 I'll have 31 balls. So the same thing applies with the green balls. I didn't touch any green balls because I was not rooted from green. Now I will have how many balls? Now I'll have 8 over 31. And then wow, now we head to the last branch. So now we have yellow balls, right? So we know that, okay, we are looking for the probabilities, and if you check the probabilities, I've written them on top of each and every on top of each and every branch, and look at how do I name the branches, right? Just simply do it like the same way as I've done, right? So what happens for the yellow balls? I know that, okay, the sample space will be 31 because of I've already chose a yellow balls, and then at first I had 18 yellow balls because of I chose one. Now I'll have 70 yellow balls. Now this is the complete tree diagrams, but we are not yet done. Now we are not yet done because of we have to provide the outcomes. You have to provide the outcomes and the probabilities. So on the probabilities, you'll be told in the question whether you must provide them. You see, but for outcomes, it's a must that you provide the outcomes. You see, or just to be safe, just provide all of them. As long as you are not running out of time, just provide all of them. Now we have to write our outcomes, right? Now, how do we write our outcomes? Whenever I'm going to teach you on how to write those outcomes. How do you present your outcomes? Your outcomes, you go branch by branch. You start with the first branch and then you go straight. So you start with the first branch and then you just simply go straight. So I'm going to start with the first branch. My first branch here, I have my R, right? I will start with here at my R to this R. Now my outcome will be choosing a red ball first, which is here, and the second ball will still remain to be red. So now I will have R as my outcome, which simply means that the first ball was red and the second ball, the first ball that I drawn from the ball from the bag is red, and the same thing applies with the second one, it's still red, right? And then I will still continue because of this branch. I have to end this branch. I have to end with this branch first. I have to complete this branch. So the same thing applies. I still have to start here at R. Now the first ball is R, but now the second ball is what? But now I make the second ball to be green ball. Now I have RG. Now the same thing applies. I'll still start with R and then I end at Y. Now I will have R Y. That's the outcomes of the first branch, right? Now we are done. So now we look at the second branch. Now the second branch I start with G. It's rooted from G, meaning the first part that I choose is G. I'll have G, and then what happens from G? Where do I go? I go here. So I'll have G, the first ball, and the second ball is red. Now I still have G again, and then the second ball remains to be G. Simply means that the first ball that I choose is a green ball, the second ball that I choose is still a green ball. Now I still have a G, but now the second ball is a yellow ball. You see, you just simply have to match this. And then now the other thing that I have, now I look at the branching, right? This is where I choose, this way this branch is rooted from Y, right? So I will start with Y, and then what do? I start here with Y, and then I end here with R, right? The first ball is yellow and the second ball is red, and then the first ball is still yellow and the second ball is green in this case, and the last ball is okay, and then the first ball is still yellow and the last ball in this case is it's yellow. You see? Now what do I do? Now you have to find the probabilities. How do you find the probabilities in this case? How do you find the probabilities? You use your outcomes. You see, so the first stage of finding the probabilities is to jot down your outcomes, and then from the outcomes you head to the probabilities. Now the first probability that we are going to have in this case, we'll have the probabilities of choosing a red ball first and a red ball. For choosing the first red ball, choosing the first probability that we're gonna have is choosing a red ball first, and then after we still choose a red ball. And then the second probability is when we choose a red ball first, and the second ball that we choose is it's a green ball. Now the same thing, we will start with a red, and then now we end with a yellow ball. You see, the same thing that happens here. Now here we start with a green ball, and then we end with a red ball. The probability of choosing a green ball, and then we still end with a green ball. Now we have the probability of choosing a green ball, and then after a yellow ball. Now we start with a yellow ball after a red ball. The probability of choosing a yellow ball after a green ball, and then lastly we have the probability of choosing a yellow ball, and then after we still choose a yellow ball. Now how do we find the probabilities of these three diagrams? Right, just gonna show you a sample trick. So now you are going to multiply the probabilities of the branches on top, the probabilities that are on top of the branches. You're going to do what? To multiply the probabilities that are on top of the branches. So now we start here. So because of its R, I'll start from R2 to the first R. It's R, right? So I'll say 6 over 32. I multiply by 5 over 31. Now this will be the probability of choosing first a red ball and then after a red ball. Now the second thing applies here. Now I still start here, and what do? I multiply with the second probability. I still have 6 over 32, but now I multiply it with 8 over 31. Now the same thing applies here. I will multiply by this one. Now I have 6 over 32. I multiply it with 18 over 31. You see, now we're still gonna calculate the value of this. Now the same thing applies. Now we look at G. We are done with Y. Now I'll say from G, looking at the probabilities on top of my G, then you see I multiply by the following number. You see, now for G, I'll have 8 over 32 multiplied by what? Multiplied by 6 over 31. Now, for GG, I'll have this. I'll have 8 over 32 multiplied by what? By 7 over 31. You see? And then for GY, I have 8 over 32 multiplied by what? By y. Now I have 8 over 32 multiplied by 18 over 31. Right? So we do the same thing over and over again. So now what do we do? Now we are left with y. Right? So what do we do with my y? You see, I multiply with the following. Now I have 18 over 32 multiplied by what? By 6 over 31. Now I have 18 over 32 multiplied by what? Multiplied by 8 over 31, right? And then I still have 18 over 32 multiplied by 70 over 31, right? So what do I do? Let's determine the probabilities. Let's start with the first expression, right? So we are going to say, okay, 6 over 32 multiplied by, okay, 6 over 32 multiplied by 5 over 31. Okay, so now the first thing that we have, just write them like the way. The first thing that we have, the first probability, it's 50 over 496. That's the first one, right? The second one still remains to be 6 over 32. Now we multiply by 8 over 31. Now we have 3 over 62, right? And the same thing applies over and over again. Now we'll have 80. Now we have what? Now we have 27 all over 248. All right, and then okay, now we multiply 8. Now we have 8. Okay, now we have 8 multiplied by 6 over 31. Now we have 3 over, now we have 3 over 62. If we check these two probabilities, they repeat, but it doesn't really matter, you see. So, and then now we multiply by, it's 8 over 32. Now we multiply by 7 over 31. Now we have 7 over 1, 2, 2, 4. Sorry. And then now we have 8 over 32 multiplied by 80 over 31. Now we have 9 over 62, right? You see, now we continue. Now we have 18 over 32 multiplied by 6 over 31, right? So what is it? The same thing with this probability. Now, okay, we have 2, 4, 8. See, it repeats. I believe the second one is still going to repeat with this one. Okay, we still have multiply. You see, 9 over 62. It's not the first time we get this probability. And then now, okay, we are left with the last one, which will be, okay, the last one is, wow, such a huge number. Okay, we have 1, 5, 3, 4, 9, 6. Right? the presentation of this number is huge. This number, like, scientifically, is not huge. You see, basically, you may find that it's small. Yeah, it's too small. Yeah, but I was just simply complimenting, the size of this expression. Now, what happens? This is your battery diagram. By all doing this, you are done. So the only thing that we have to do is to analyze the data, look at the branching, how many branches that is controlled by the events, right? How many events do you have on the first branching? If you have 3 events, the first branch will be 3. And then now you root the branches from each event. So meaning now, because of this taking another ball, each branch will have three choices, since you have started with those 3 choices. And do not forget to maintain consistency on the sequence of these events, right, to avoid confusion. Now let's look at the next question, which is, okay, this one is 8.2, right? We were on 8.2. So it's how many marks is it? Let's check the marks. Usually it's 6 to 5 marks. It's 5 to 6. Okay, it's 4 marks, a whole 4 marks. Yes. Okay, now let's look at 8.3. 8.3 reads as follows. Calculate the probability that the 2 bars drawn from the bars will have from the bag. So 8.3 reads as follows. They say calculate the probability that the 2 bars taken out from those 2 bars which are taken out from the bag will have the same color. Now we are looking for the probability that when I choose a ball with a certain color, the same thing applies with the second part that I choose. When I choose red, on the first ball, the second ball has to be red. When I choose the yellow ball first, and then it simply means that the second ball that I'm going to choose still remains to be yellow. When I choose a green ball, the second ball that I'm going to have still remains to be a green, still remains to be a green ball, right? So we want the probabilities of choosing, we want the probability that the two balls drawn from the back will have the same color. Meaning I want RR, I want GG, and I want YY. But these are the outcomes. We want the probabilities of these outcomes, right? You see, so we were not told in this case, we were told to do the outcomes. We were not told at 8.2. On 8.2, we were not told to find the probabilities, but we did try to find the probabilities on our own, which means these 4 marks, some marks will be distributed amongst those probabilities. Because look at this, what we are going to do is just as a just small silly thing. You see, all of you will be surprised. You will be surprised since it's 4 marks. Note, like I repeat for the second time, I'm gonna repeat. On the question, we were not told. We were only told to provide the tree there to draw the tree diagram only with the outcomes. And then what did we do? We did some extra work on providing the probabilities. Now the question here, we have a question which needs those probabilities. Now we want the probability of choosing the same color, meaning when I choose when the first ball that I choose it's red. When I choose a red ball, it simply means that the second ball that I'm gonna choose has to be red. And then the same thing when I choose a green ball, it has to be a green ball the second one. When I choose a yellow ball first, even the second ball has to be a yellow ball. So we are looking for the probability that when I choose a red ball first, the second ball has to be red. When I choose a green ball first, even the second ball that I choose has to be green. When I choose a yellow ball, even the second ball has to be yellow. So what happens? We have PS, and then the only thing that we are left to do is to substitute the probabilities. The probability of finding RR is given. That's 15. No, it's not given. We just found it. So it's 50 over 496 plus, okay, the probability, which is GG, of, okay, we have 7 over 24, and then we have, that's 7 over 24, no, 7 over 124. That is the probability of choosing a green ball, right? But then a green ball first and out. So, and then now we have the probability of choosing a yellow ball first, and then the second part that we choose remains to be a yellow ball. That's 153 over 496. And then the probability of choosing the same ball is, let's add them. Let's find the sum of these. Now I have 50 all over 496, right? Plus 70 all over 124, not 70 but 7, sorry. Okay, plus 153 all over 496. So what do we have in this case? We're gonna have, okay, we are gonna have 3 1 0 1 all over 7 8 7 4. Now that's 8 point what? Yes, 8.3. Now we are done with question 8. So let me check this. I wanna check this first. Just wanna do this first. Okay. Yeah, students, I believe that was enough for the day. Yeah, do not forget to do the following. Do not forget to subscribe. Let's see, do not forget to subscribe, like, and what? And share. And I'll continue on giving you the part. So that was enough for tree diagram. We're still going to have more lessons on tree diagrams. Like we'll be treating past papers. I will be treating past papers on tree diagrams. You see, sharp. Let me do this first. Okay, bye bye.